Nassim, welcome.
Thank you.
Welcome in the first edition of Frontier Radio.
Oh, thank you for having me. It's an honor to be the first interview on Frontier Radio.
Thank you. You are for a few days in Holland giving some lectures, get in contact with Dutch people who are interested in the work you do. But first time there has been lots of published also on my website about you, about your work, but also I read on the website of the Resonance Project is that you started already at 9 years old for theorizing about science, about physics. And the first I read was holofractographic universe.
Yeah.
One mouthful.
Yeah, no doubt. For me it started really early because I had some fundamental questions about the universe. I think even earlier than that I was, inquisitive about reality. And I don't think it's so unusual. Actually, I was, I've been touring for months now all over the US, and I was driving, because I'm gone for so long, at one point my family met with me, and so I had my son with me, and he's 4 years old. And I was driving across the desert for 16 hours, there's long distances over there. And at one point, he was asking a lot of questions. He's at that age where he says, why this, why that? And I said to him, you have to really think about the question before you ask. And so he thought for a minute, and then he said, I have a good question. I'm like, what? He goes, what is reality? And he's 4 years old, so I think it's actually not so uncommon for children to wonder what is this world we live in? What is the material world, and so on. And before I had time to answer, my son said, he touched the door and he said, Papa, the door, it's not real. And then he touched the window and he said, the window, Papa, it's not real. And he started to make an argument that the material world is not so real. And, I was blown away. But I think that, children and maybe closer to the...
More in contact with the knowledge.
Exactly, yeah. And so when I was about 9 years old, 9 or 10, I can't remember, I had my first lesson in geometry. And the teacher went to the blackboard and made a dot and said they were going to learn about geometry, and the first lesson is dimensions. And he said the dot is dimension 0 and it doesn't exist.
Oh, that's a very interesting theme for kids, I think. More dimensions and so on.
Yeah.
I remember it.
Yeah. But already when he said that, I knew I was going to fail geometry because I didn't agree with the first statement already. If he made a dot and I could see the dot, how is it that it didn't exist, right? And then he did something even more miraculous. He put a bunch of dots together to make a line, said this is dimension 1. It still doesn't enclose volume, so it still doesn't exist. And then he took 4 of these lines, made it into a plane, a square, and said this is dimension 2 and it doesn't exist either. And then he did a miraculous thing, an amazing thing. He took 6 of these non-existing planes, right, and slapped them together into a cube and said this is dimension 3, it encloses volume, and thus it exists. And it was like, and that's the dimension you exist in. And I thought, wow, how is that possible? If you have a dot that doesn't exist, that makes a line that doesn't exist, that makes a plane that doesn't exist. I asked a physicist much later on, actually a mathematician. I said, how thin is a two-dimensional plane? And he said, I don't know, infinitely thin. And so, if you put 10,000 non-existing planes together, you still don't get existence. And so, for me, that whole axioms of dimension had to be wrong. And I didn't know that this is the axiom we use for most of our mathematics and physics and all this. I didn't know that many, people had the same problem. And Buckminster Fuller, much before me, had the same problem at school when he heard that axiom. And my father had the same problem and so on. But on the way back from school, I thought, I got to solve this. And I imagined myself as I was in a bus. And I imagined myself coming out of the bus and rising above the bus. And I saw the bus becoming a dot. And I rose further and I saw the Earth becoming a dot. And I rose further and I saw the solar system becoming a dot. And then the galaxy becoming a dot. And I thought, oh, wow, it's dots all the way up. And then I flew back in and opened my eyes and I looked at my hand and I thought, I wonder what's in there. And I closed my eyes and I flew into my hand and was made out of millions of little dots we call cells. And then I flew onto the surface of one of those and I looked really carefully at the membrane and it was made out of billions of little teeny dots we call atoms. And then I looked really carefully at one of them and I went into the middle of it and sure enough there was a dot in the middle. And I thought, oh, it's dots all the way down. What the universe does is dots and then puts them together and makes the whole universe. And the axiom should be the only thing that exists is the dot, right?
Yeah.
And that's divisible to infinity. And that started me on this whole adventure of describing the universe in a different way.
Yeah. And then you call it the holofractographic universe.
Yeah, I call it the holofractographic universe because eventually I realized that it had to be a fractal structure. Mm-hmm. I didn't know I was describing a fractal structure when I was 9 or 10.
Oh, okay. Mm-hmm.
But I eventually realized that that's what I was describing, like infinite recursive division of the space. It's a simple exercise you can do. You can make a little circle and put a triangle in it. And then put a reverse triangle. Now you have a Star of David or a six-pointed star in a circle. The first circle you can say is my finite boundary. And then you can put a little triangle on each end of that first Star of David and you'll get littler Star of David that makes a new boundary. Mm-hmm. And then you can continue to make smaller and smaller and smaller Stars of David by adding the divisions of the space. Mm-hmm. And each division, each boundary is going to be very specific. It has its own coordinates in space-time, its own relationship to all the other boundaries, but they're all recursive. You can continue to divide the space to infinity. I mean, if you do it in a computer, you can get the computer to zoom and then continue to divide and zoom and continue to divide. Mm. You will never come to the end. However, you will never, ever, ever, ever exceed the first boundary that you've made. So from what appears to be a finite boundary, there's an infinite amount of divisions possible, an infinite amount of information, which would mean an infinite amount of energy, right? So it was clear to me, and then much later on, it became clear to me that atomic structures must have these infinities in them, that you could continue to divide them. Mm-hmm. And now we have accelerators that divides the atom into subatomic particles and so on, and we have these little bits that are millions, billions of times smaller than an atom. So and we keep building larger and larger accelerators to get smaller and smaller bits, and I think we can continue to do this to eternity. We're not going to find the end of it. It's more important to understand how it divides. Mm-hmm. Because if we understand how it divides, then we understand the fundamental geometry of it. And now we would have a key to the structure of creation. Very important thing to have. So for me, that started the search to geometry. So the name holofractal graphic comes from this view, is that it is a fractal boundary condition. It is holographic because it has, each boundary produces these wave function that interact with each other, that produce this information network in which everything is known by everything because it's all embedded.
But what you're saying about this theory, as you look in nature, you look at the leaves.
Yes.
A child can see it. That it works that way.
That's right.
Yeah.
You can see it everywhere. Yeah. You look at the branches of a tree. You look at the roots of a tree. You look at the nervous system of a human being. You know, all the way it branches, all fractal structures, the way your veins, your arteries, the neurons in the brain, all this stuff, it's all, you can all map that in structure, fractal structures. So that's a hint, you know, that this might be a fundamental thing. Yeah.
But then is the question, of course, why?
Why? Yeah, exactly. Or how?
And how?
Know? Yeah. You know, I think that early on it's like, okay, now what is dividing? You know, and I realized, well, you know, when you look at the material world, we tend to think that the material world is the thing that's doing all of reality, but when you look at an atom, for instance, and if you're really honest about what you're looking at 99.9999999% space. And the 0.00001% that you're looking at is a little electromagnetic field oscillating, right? That we call the electron cloud and all this stuff. So basically, you're looking at oscillation of the space. You know, we keep thinking that the material world defines the space.
It's otherwise.
Yeah, but we could think the exact contrary, and instead of looking at the 0.0001% as something significant, look at the 99.9999% that's there as the most significant part. And so that space defines atoms. You know, space defines the material world instead of the material world defines the space. And so then I started to think, okay, maybe space is not empty. Maybe the fractal division we see in the material world is just an effect of the space, the geometries in the space, that there is a self-organizing system that's the structure of the space. It starts to answer a lot of questions about how does matter self-organizes, you know?
Yeah, but if you look at the science of today, the physical science, how do they think about these kind of theories? There is, I think, a little bit more going to move in the scientific world about this, isn't it?
Yeah, there's definitely a change occurring in the scientific world. There's a willingness to look at more and more alternative theories at this point. You know, almost 20 years ago, when I started encountering the scientific world, you know, and kind of coming in head on with it, the scientific world was much more arrogant at the time. In general, 20 years ago, people thought in physics that we almost have everything figured. We're very, very close.
You're already.
Yeah. We don't need no crazy theory. We don't need new theory. You know, we have it almost figured. We just need a little bit more, and we'll have a unified theory of everything. And because especially with the event of string theory and so on, you know, they thought, oh, we're very close now. And And now they're starting to see, and then in the last few years, they're starting to see the failing of, string and so on, and many, data coming from the Hubble and many probes that we're sending out there is coming back with stuff that blows a lot of our standard theories out. And so now there's much more humility, there's much more openness to look at different
maybe there's also a new generation of scientists coming now.
That's right. There's a new generation of scientists, and the older guys are dying off, and so it's opening the doors for new views, and and as well, I think this society as a whole is pushing for changes because we're encountering a lot of stresses in our society at this time. We know we need to find solutions very rapidly for very big problems. So there's a great push to look at new type of ideas.
Yeah, but those ideas can help to solve the problems we now have. All the problems we now have, are they the result of old kind of theories and habits?
I think so, yeah. A lot of the problems we have are the result of these ideas, we're a very young technological society, within 150 years we went from horse and buggy to going to the moon and space shuttles and, being able to go across the planet on planes and all this stuff. It's a huge change in a very short amount of time, and it's very, very young. And so our technology is very primitive. It's not very harmonious. And it's based on theories that are not complete. So it's not harmonious with nature because the theory that it's built on are not, they don't understand nature very well, but I think that's all about to change. I think that science is about to take a giant leap in evolution, and I have lots of evidence for it. And and the technology that follows is going to be beyond what you can imagine today. It's not in 10th generation from now. It's in our generation already. Yeah, it is going to change. Within the next 5 years, you will be amazed what's coming our way.
Yeah. Nassim, the unified field theory. Can you explain something about that?
Yeah. Well, in the standard physics, the unified field theory is a very specific field of investigation. Is a field of physics in which you're attempting to unify the four forces of nature. And currently, we have gravity, the electromagnetic field, the strong and weak force. And these forces are not currently unified. We have theory like Einstein field equations that deal with the big stuff, like stars, planets, and these, Einstein field equations describe the gravitational effects of the stars and planets and so on, and Maxwell's equation describes the electromagnetic field, and usually, and then you have the quantum world, right, with the quantum theory, which describes the atomic level and the subatomic particle and so on. And in quantum theory, you have the strong and the weak force. The strong force binds the protons together, the nuclei of the atom together, against their electric repulsion, the electrostatic repulsion. And the weak force, which is the force, the decay and so on of the atom. And so these forces don't agree with each other. Einstein field equations and gravitational equations describe a continuous curvature towards singularity, and quantum theory describes bounded conditions right? Linear functions. And so the two don't agree with each other. And unified field theory is a theory that would bring all these forces together. And so far, none of the standard views have been able to do that. Einstein worked on it, and so on. And, my theory does it, especially with this paper I just published, in a very simple and kind of elegant way. And it does it by basically getting rid of the strong force and showing that actually the strong force is gravity acting at the atomic level. If you consider the atom, the nuclei of an atom, as mini black hole. So if you look at a proton as a mini black hole, all of a sudden the protons have the attraction force of gravity necessary to overcome the repulsion of the electrostatic force or the Coulomb force.
But it says also something about your fractal theory, that you have black holes in big and in small.
That's right.
Yeah.
The idea came to me from the result of thinking everything is divisible to infinity if each division represents a certain set of information, therefore a certain set of energy, therefore has mass. Then if it's divisible to infinity, then everything must be a black hole. Everything must be, have infinite mass. And so I, developed this, and eventually I predicted that we were going to find black holes at the center of all galaxies some 20 years ago. And people said, oh no, black holes are most likely very, very rare, and da-da-da-da. And I'm like, no, they're going to be
more common than rare.
Yeah, I said, no, they're actually pretty well everywhere. And so eventually they did find that every galaxy they look at has a black hole in the middle. And I said as well that they were going to find black holes prior to galaxies, because after they found the black holes in all galaxies, they started to say the black hole is the result of the stars colliding in the middle, making a black hole. And I said, no, the black hole is there first. And then the galaxy comes and becomes the galaxy. And fairly recently, only a year ago, they discovered that it seems like black holes were there prior to galaxies, and so on. So, a lot of the things I've predicted are coming true, and so my theories are becoming more and more popular. Yeah. But now I've written a paper that just won an award that shows that you can treat the protons of the nuclei of an atom as mini black holes, and when you do, you get the right value for the atom to be able to be held together without the strong force, so automatically you unify the fields, and as well you get all the right values for measured values in laboratory for the nuclei of atoms, but using classical mechanics, no quantum theory, just using, mechanics, Newtonian mechanics and semi-classical mechanics from Einstein field equations. So this actually fulfills Einstein's dream, because Einstein thought my equation can do this, can solve the atomic level. There must be some fundamental mechanics to the atomic level. He didn't agree with quantum theory. But Einstein, although his equation predicted black holes, didn't really have black holes in his toolbox.
Okay.
Because even the word black hole
wasn't there.
Yeah, it wasn't there. It was called, they talked about it as a singularity, but the word black hole, I think, was coined by John Wheeler, much later. But Einstein didn't like the fact that his theory predicted singularity, that it predicted infinities. He thought that makes my theory invalid at that point. And so he shied away from it. And so did, whole generations of physicists. And at the time, they didn't even believe that we were ever going to find a singularity in the universe out there. Never mind trying to apply it to the atomic level. So, but then eventually they started to find black holes. And they thought, oh wow, they actually, it's not just a mathematical allegory, they actually exist. And then, they found them at the center of all galaxies, and they started to find many of them even inside our galaxy, like smaller, mini quasars and so on. And then eventually, and then I come along and I say, well, actually, the nucleus of an atom is a black hole, and the math works out. Now, there's still a lot to be worked out, but initially it looks very, very good, and I think that's why my paper won this award.
Yeah. But if you look at the atomic level, people we trying to get energy out of nuclear energy, make nuclear energy.
Sure.
What does it mean with the theory? What are we doing with this? Because we are splitting atoms, we're splitting protons, we're splitting black holes.
Yeah, we're basically splitting black holes into smaller black holes because we give them, we collide them. And we give them enough energy when we collide them to collapse them into even smaller and smaller and smaller particles. But we call them all sorts of different names, all these particles. But basically we're dealing with just smaller divisions of the space. And I think that understanding this and understanding the equations I wrote, because you got to realize, remember, I was saying maybe the space is not empty. I showed that actually it's the space that makes the structure of the black hole, meaning that the space and time is not empty, it's full of energy. If you were to point at something that connects all things, the thing you would have to come to conclude that connects all things is that space connects all things. It's everywhere.
It's everywhere. Yeah, that's correct.
Yeah. So when you look at the space at the quantum level, it has to be very, very high in energy, in density. When we look at the space in the quantum level, the density of the space that we use in our equation to make everything work and so on is 10 to the 93 grams per centimeter cube. And that's a lot of energy. If you were to take all of the mass of the universe, which is 10 to the 55th gram, and you put it into a centimeter cube of space, you only have 10 to the 55th gram per centimeter cube. You'd still be 39 orders of magnitude less dense than the density of the vacuum. Now you may say, where did this number come from? Well, it's a little complicated, but let's just say that it's been verified in laboratory through the Casimir effect, and that actually this energy in the vacuum is there. It's not. Yeah.
What is the Casimir effect?
The Casimir effect is when this number, this 10 to the 93 grams per centimeter cube, was calculated almost 100 years ago. A scientist called Casimir thought, well, how could we verify that it's really there? Or is it just our crazy math, or is it really there, this energy in the vacuum? And so he thought, well, maybe if we got two plates close enough together, very, very close, then we should be able to eliminate the long wavelengths on between the two plates of the vacuum, right? Like the vacuum would have all this energy. There would be long wavelengths and there would be shorter wavelengths. And so he thought, if I get two plates close enough, the long wavelengths won't be able to get in between. So I should get a pressure on the outside because there's more energy of the vacuum on the outside and less in between, and the plates should get pushed together. And so he calculated how close the plates would have to be together before you could measure the pressure. And the calculation showed that the plate had to be microns apart. But nobody could mill two plates micron precision in 1947 when he made the calculation. It took until 1990 when Dr. Lamoureux in Seattle University was able to first got a ball and a plate together that close. And sure enough, he got the Casimir effect. And then eventually plates were put together and it was reproduced in many universities. And the plates get pushed exactly at the rate that was calculated by Casimir. So that energy is there, and it has real physical effects because it does push those plates together. It has real mechanical effects and not just quantum effects. Those plates are macro plates, so it exists. So to understand this, to understand how, instead of thinking of this energy in the vacuum as in the standard model as a random energy that's unusable, that cannot be, I showed that actually it is the vacuum dividing. It's random everywhere except that when it organizes, it makes a boundary that we call the material world. You see? It makes a star, it makes a galaxy, or it makes an atom or subatomic particle and so on. Whenever it makes a boundary, because it self-organizes, because it's, coherent in that region, then we say, oh, there is something. Just like imagine the water in a pool, right? Mm-hmm. All the molecules are random in the pool everywhere. Yeah. But if you have a little vortex, if you make a little vortex, then the molecules along that vortex are organized. And you would look at the vortex in the pool, if you didn't know the rest was there, you'd say, oh, there's something there, right? It's the same thing for us. Wherever the vacuum energy becomes coherent into a little vortex, we call it an atom, a planet, a star, a galaxy, or a universe.
Okay, and then it's gonna be you can see it manifesting. Yeah. Right.
It become visible because when it becomes coherent, then a very teeny portion of the energy available becomes starts to radiate. Right. We call it the electromagnetic field. And now there's an effect that you can measure, that you can see, and you say, oh, here's something. But nowhere in our physics does it say where that something came from. For instance, if you ask a physicist, where did all the matter that makes up the universe come from? You just say the Big Bang. Well,
Yeah, where did the Big Bang come from?
Right, exactly. That's like going to church and asking, where does the material world come from? And they'll say, from God. Well, that doesn't tell you anything, right? Well, here I'm proposing that actually everything emerges from the vacuum and returns to the vacuum. And that it is a continuous creation process, not just one bang. So it's a completely different view.
Okay, so there is some kind of creation in it.
Yes, that there's a continuous flow between the material world and the vacuum. The electromagnetic field radiates into the vacuum information, and then the vacuum reacts by feeding back the information back to the particle or to the boundary, whichever size it is. And so that there's a constant exchange between the vacuum that connects all things and the individual boundary that's exchanging with the vacuum, and so that everything knows where everything is, and the vacuum is actually organizing it all.
Okay, does it also say a little bit also of about the theory of Rupert Sheldrake?
Oh yeah, morphogenic fields.
Yeah.
Absolutely.
Yeah.
It supports the idea that there's a fundamental morphogenic field that but in this case it actually gives the mechanics on how that field is actually produced. It's not like magic. It actually
it's been
it has physics attached to it.
Also Akasha.
Yeah, or the Akasha record, or even karma, which is information going out, produce information, come back again, and so on. Many different concepts of high spirituality all of a sudden starts to have very fundamental physics attached to it, and that's really important because it removes the dogma. And it actually gives you the real physics. I always say, all concepts of spirituality and religion are physics we haven't understood yet.
And now it's in this theory it comes together. That's
right.
Why the unified field theory.
That's right. In this theory it comes together, and it doesn't just unify the fields of physics, but it actually unifies consciousness and spirituality, and it starts to really give a global view, a theory of everything view.
Nassim, we talk about the information, what's inside of the emptiness, the space, not emptiness, space.
Yes.
But you were not ready explaining things, so maybe it's good to
give some more details. Yeah, actually a good example on how this physics starts to give some good foundation to spiritual concepts. When I was doing the calculation for the proton, the mini black hole proton, I calculated from that 10 to the 93 grams per centimeter cube of vacuum energy. This is in a centimeter cube. I calculated how much of 10 to the 93 grams is still left in the proton volume, right? And not in the centimeter cube of space, but in the proton volume, which is very, very small, billions of times smaller. And so when I did the calculation, the amount of energy, remember I was saying that vacuum connects all things, the amount of fluctuations in the volume of a proton that's still there from the vacuum is 10 to the 55th gram, the exact mass of the universe. So actually, it was like a confirmation that all the protons are correlated, that all the protons are entangled, right, through the vacuum, because the mass of the whole universe is there for inside the volume of each proton inside the vacuum.
The fractal theory again.
Exactly. The fractal structure showed up again, and that was really confirming, but as well it gives meaning to all the spiritual people going around saying it's all one, we're all one, because it's like, to know we're all one is one thing, but when you understand how, that's so important, because now you actually have a physical meaning to it. Not only do you understand, you don't need to believe it blind anymore. You actually have the fact that even the physical world is actually all one. It's all entangled, and here's the mathematics of why. And you can imagine that leads to technology that, could bring you from one end of the universe to another.
And that's why maybe some alien populations can visit the Earth because they already know that knowledge?
Right. I mean, certainly. Imagine that the planet has, instead of 150 years of, technological advancement, maybe 1,000 years of technological advancement, which is not much time in cosmological time. Still, 1,000 years is nothing. They probably have figured this out, and they probably figured out how to use it. How to use this web of connectivity of the vacuum through the whole universe, and how to navigate it. And they can, and that leads to being able to, disappear from over here and reappear on the other side of the galaxy, and to us that seems unconceivable. But if you went to people just before the Wright brothers flew the first plane and told them, like, in a week or two, these two brothers are going to come here and they're going to have this strange device and they're going to lift a few thousand pounds of material off the ground and fly like a bird, they would say, you're insane, And then a week later it was done. So, I think we're very close to changing some very fundamental ways of doing things on our planet, just because we're going to understand deeper the nature of reality and the forces that runs this reality, that makes it work, and we're going to harmonize better with nature. Because we're down here on this planet moping around, going, there's not enough space and there's not enough energy. But if this is true, what I'm telling you, there's infinite amount of energy, and there's infinite amount of places to go, and there's no need to fight for space, So
that's good news.
Yeah. That's the good news. And it's not, like I said, it's not going to be 10 generations from now. It's in our
generation.
Yeah. It's very eminent.
Well, has it something to do also with the prediction of the Maya, for example, that they already knew how things...
Well, two things. It has to do with many of the predictions you find in ancient civilization that talk about this time as our time of ascension, and I don't think they meant just spiritual ascension. I think,
totally.
Yeah, actually literal ascension, that we're going to actually learn to get off the surface. But as well, I don't think, many people look at these ancient civilization and they talk about how wise they were and all this, but actually, if you read their own books, their own texts, their own, their own traditions and all this, none of them said we were smart. All of them said sun gods came from the stars and told us everything we know, gave us calendars, told us what's going to happen in the future, and told us how to build our buildings and all this stuff. So, I don't know. I think sun gods have been around for a while.
Okay. There is an initiative that's called the Resonance Project.
Yes.
That's also the Resonance Project has been raised because you want to explore, to give it the information to all people on the world, also the scientists. Can you explain something about it?
Right. The Resonance Project is a non-profit foundation that's dedicated to unification theory research, but not just unification in physics, unification of philosophy and religion and all this. And, it is supported by the public, for the public. The goal of the Resonance Project is to disseminate the information to the public that is being found by the researchers inside the project, and and we're in great need of support because so many physicists and biologists and mathematicians and all this are ready to really move forward with all this information, but and we're restricted by the amount of funding we have, and so any support that people can give to the Resonance Project is really helping the planet as a whole.
Yeah. You also see it on the people are knowing a few weeks that you're coming here, and the place is full. People are coming to your lectures because lots of people are very interested in the theory. I think also a lot of people are busy with spirituality and now see someone try to get proof of what we say, what we feel, what we have in our...
Yeah. I think that instinctively people know, and spirituality is based on this, is that instinctively people know how the universe works, but not necessarily have the knowledge or the terminology to describe it, and I think we're just reaching that level, and a lot of people are excited because they see in this theory a possibility of this unification of spirituality and advanced physics. And, this starts to give the mechanics of how, like I said, how is everything one? People are saying, you're creating your reality. How are you creating your reality? Or the universe is consciousness. What is consciousness? If you don't define what's consciousness, you're saying exactly the same as the priest that says the universe is God, or the physicist that says it's just a Big Bang. Or you still don't know what that is. What is consciousness? So, all this starts to come together in this theory because you can actually start to see the mechanics on how this is possible, and it really gives a foundation to the spiritual mind. And without it, I think that we continue to have a failing society. And in one side of the society is very spiritual and not very grounded, and the other side is, under the ground, and not able to, come up with very creative ideas because it's so stuck in the bounded condition instead of the possibilities. So.
Things can come together now.
I think they are coming together, and the technology that's going to emerge from it is going to be beyond what we can imagine today, and has the potential to free humanity, completely from a humanity based on concepts of scarcity to a humanity based on infinite potential, infinite abundance possibility. Because our universe has infinite, abundance in it. And you don't see atoms start to run down, and say, okay, well, I'm running out of energy. I'm sorry, I'm out of here, right? It doesn't happen. There's plenty of energy, but we haven't understood what is energy. How did it come here, and all this stuff. And this series starts to really put your finger on it. How does it occur? What are the mechanics? And then when you do that, and now you have the key to play with the universe.
Are there also something practical people who are inventing new technologies already based on this theory?
Certainly, there has been some 10 years of technological engineering and advancement that have started to produce some results, and so there is some work that's being done in that field. It takes time because one of the major reasons it takes time is because of funding issues. It is extremely difficult to be funded as an independent. I'm not part of any large institution, and I work as an independent and so on. And it has its benefit, that is, I can think whatever I want, and I can, I don't have any constraints in what I can study or not study and so on. But, it demands a lot of work to actually find funding because it is unusual. And so I'm hoping that we can get more and more support from the public, and actually do it with the public, for the public, and that's really crucial.
Yeah, maybe it's something you can relate on the days of the Catholic Church.
Mm-hmm.
Was very powerful, and then the Enlightenment came out of the scientific world,
mm-hmm.
and now there is another kind of enlightenment going on,
mm-hmm.
because the scientific world of today is a little bit the Catholic Church of 300 years ago.
That's right. Very similar. But we're even inside the scientific world, when you look at some of the greatest advancements that occurred there, many of them occurred from independent researchers.
Most planets are first seen by amateurs.
Right, exactly. And so I think it's a big lesson there.
Mm-hmm.
That is that, like, whatever box you're in, be ready to look outside that box, because that's probably where the next step's gonna be. Yeah. And Einstein said it himself. I'm paraphrasing, but in general, his statement was, a problem cannot be solved within the box in which it was created. And so, I work as an independent, and the Resonance Project is an independent project, and so on. But if the public supports it, then we can advance much faster, and we can do really remarkable things by being able to function the way we need to function, without strings attached to all sorts of different institutions or governments and so on.
Free to think.
I'm sorry?
Free to think.
Yeah, free to think the way we need to think.
Mm-hmm.
And all the scientists involved, like my co-author, Dr. Rauscher, Dr. Hyson, and many other physicists that are interested in participating, we could really move forward and get some amazing work done if we have appropriate funding.
Okay.
Yeah.
More information about this is also readable at the resonanceproject.org. And if you have some money, please donate.
Yeah, donate. I mean, even if you donate $5, $10, whatever you do makes a big difference. And if you have $100,000 to donate, then donate that, whatever. But this is probably one of the most important thing you can do for humanity. If you understand what we're doing, I think that is very, very powerful way to contribute. Okay. And I'm enthusiastic about it.
Well, I can imagine that you also need people who are translating lots of things out of the world, also for people who getting the information through the public.
Yeah, actually, you don't. If you can participate in many ways, you can actually buy a DVD set, right? So there's a 8-hour DVD that has all the information and lectures and all this stuff. You can participate in the delegate program and the emissary program. The delegate program is a 2.5-day course that I give that gives people in-depth information about all the theory and all the research I did on ancient civilization and all this, so that they can turn around and talk about it with some knowledge behind themselves. And as well, and then from the delegate program, you can come and do the emissary program, in which people spend like 10 days with me, and I train them so that they can give talks. Okay. And actually,
the information can be spread around of the world.
That's right. The information can be spread in the world in a fractal way.
Yeah, exactly.
And that is a way to be very proactive in getting in helping out, getting this information out. So,
you also ideas for writing a book?
Oh yeah, the book has been in the works, for almost 10 years. It's just I've been so busy writing physics papers and taking care of all the business and touring and all this stuff. I have not been able to finish it, so I'm hoping it's going to be there soon. I keep saying every year, next year it'll be done, but, hopefully soon. Hopefully soon.
Nassim, thank you very much.
Thank you. It's great to be on your show.
And good luck with all your works, what you were doing.
Thank you. Stay in touch. And, until the next time, may the vacuum be with you.
Okay, thank you.
Bye-bye.
Van Argusoogradio.org